So in this video, we're going to look at question D of question 3, 2023, section 2. So it says in an unrelated example, a balloon of mass m1 with a small amount of ballast m2. So I suppose that's just extra mass in some sense. And then it says it descends with constant velocity v due to a drag force Ft acting on the balloon. The drag force is proportional to the speed of the balloon through the air. What is the mass of ballast M2 expressed in terms of Ft that must be jettisoned from the balloon so that it rises with the same velocity v? So, okay, so initially there is a balloon that is essentially descending through air at the constant velocity, and then we want to calculate the extra mass M2, and it says M2 is jettisoned from balloon, so I suppose it's basically dropped from balloon, and such that it allows the balloon to rise with the same velocity v. So I think we can use a bit of momentum conservation over here. So first of all, I think what we can do is that it says the balloon is descending with constant velocity, so we can say that the weight of the entire balloon, so that should be m1 plus m2 g should be equal to Ft. And we want to express m2 in terms of Fd, and then we also have to involve the velocity. So it says the drag force is proportional to the speed of the balloon through the air. So I suppose Fd is then equal to some constant times the velocity, as is proportional to speed. So we can say that k is equal to m1 plus m2 g over v. And then I think we might use this later. So then it says the mass m2 is ejected from the balloon such that it rises with the same velocity v. Okay, so okay, so then what happens is that the mass of the ballast m2 expressed in terms of Ft. Okay, so in the second case where m2 is ejected, the forces acting upward is the buoyancy of the balloon, and downwards should be the weight and also the drag force. But we aren't given any information about the buoyancy. So I suppose it is a constant that we should include. So to adjust the previous equation over here, we can say over here is that mg should be equal to Fd plus the buoyancy. Plus the buoyancy, let's say it's just B. So, okay. So this should be equal to kV plus B. And then I will leave it as that. So then the second equation should be in terms of this. Then B should be equal to the weight m1 plus m2 g, and then plus the new drag force. No, actually, this is the m2 is ejected, so therefore it's just m1g plus kV. So I think what you can do is subtract one equation from another to isolate m2, but there will still be some variables present. So let's try this. So if we subtract the equations, what we can get is m2g minus kV is equal to, this should be kV plus V minus B, which is kV. So therefore m2g should be equal to 2 kV. And yeah, So then, okay, so we can know that M2 is equal to 2 over G kV, and kV is just FD, so therefore it's 2 over G times FD, and that should be the answer to the question.